A black hole is a gravitational field so large, nothing can penetrate it, not even light. The top of a black hole, called their event horizon, determines the range in which the distance required for escape reaches light speed, which is the galaxy's speed limit. Matter and pollution are dropping in, but not being able to get out. There have been thoroughly descriptions of two major classes of black holes. The Sun's massive black holes are scattered over our galaxy of the Milky Way, with the cores of our biggest galaxies, like our, holding supermassive 100,000 billion monsters weighted by the Sun's mass. Astronomers believe that there is a small black holes ranging between 100 and over 10,000 solar masses, but to date they have not been certainly detected. When a star of more than 20 solar masses waste the nuclear fuel in the core and collapse under its own weight, a planetary mass of the black hole emerges. The collapse triggers an eruption of the supernova that destroys the outer layers of the star. But if the split center has more than 3 times the mass of the Sun, the collapse into a dark hole cannot be prevented by any known force. The cause of supermassive black holes is poorly understood, but from the beginning of a galaxy's existence we know they exist. Once they are born, black holes will evolve, including gas striped from neighboring stars and even other black holes. The Event Horizon Telescope (EHT) was the first astronomer to record the image of a black holes in 2019, an international collaboration that networks 8 ground-based radioscopes to a single Earth-scale screen. It seems like a dark sphere formed by a bright and burning disk. The supermassive black hole, which contains about 6 milliards of solar masses, is situated at the center of a galaxy called M87. The event horizon stretches far beyond the planets to many of our solar system. Another first black trout linked to black troughs emerged in 2015, when scientists first observed gravitation waves, space drops, which Albert Einstein's general relativity principle predicted a century earlier. The waves were seen at the LIGO detectors in Livingston, Louisiana and Hanford, Washington, National Science Foundation's Laser Interferometer Gravitational Wave Observatory. Its genesis was the collision of two orbiting, 1.3 billion years ago, black holes. In the meantime, by gravitational waves, LIGO and other systems have observed several blister hole fusions. These are exciting new approaches, but researchers research the different forms of light they produce over decades in black hole. While light cannot reach the event horizon of a black hole, the immense tidal forces around it heat up to millions of degrees of matter and emit radio waves and X-rays. Some of the debris that surrounds the surface can be tossed out and create bursts of particles that move near the light speed and emit radio, X-rays and gamma rays. Supermassive black trough jets will stretch into space for hundreds of thousands of light years. NASA space telescopes in Hubble, Chandra, Swift, NuSTAR, NICER, and others are continuing to take black holes and their atmosphere so that we can know more about the mysterious phenomena and their role in galaxy and planet evolution.